Hey guys, so today we're out spreading a dry fertilizer, a mixture of nitrogen, phosphorus, and potassium, and I'll hop up and show you what it looks like in a second. But it's basically a salt. It's a dry granular material that you spread out. So we've got these spinners spinning back here, and when you're driving through the field, this belt is going to be running that fertilizer off of it, fall through here, if you can see that, onto the spinners and scatter it out. And this one's set up to spread at 60 feet wide today. And it's one of my favorite field or farm operations, you know, putting on dry fertilizer and spraying, because you can go fast. I mean, not fast by car standards, but for a field operation, it's really quick. We're talking, you know, 10 to 20 mile an hour. Whereas like a lot of stuff that you do in a field is going to be like 5.5 or 6 miles an hour. And if we get really close, you can see like this little speck of red, and there's a few of them around here. That is that fertilizer after it has been spread, and that stuff is tiny. Today we're putting on about 265 pounds of it per acre. And this thing is set up to spread it out really thin. So it's a mixture of MAP and potash. MAP is an 1152O and potash is 0060. And what those numbers mean are the percentage of nitrogen, phosphorus, and potassium in that order. So like with our MAP, our 1152O, it's 11% nitrogen, 52% phosphorus, and 0% potassium. And the 0060, 0 nitrogen, 0 phosphorus, and of course 60% potassium. So that's by weight, and that's how we figure out how much of those nutrients we're actually applying to our soil. So we're getting a shot of all three macronutrients, putting it on in this dry granular form. So one of the things we have to pay attention to make sure this thing is calibrated right is we've got to measure the density. So we've got this density meter, and you fill this thing clear up, and then it's just like a big balancing beam, and that will tell us how many pounds our material weighs per cubic foot. So that's going to vary a little bit depending on the blend and the product. And even if you're running the same exact product, you know, your densities always just kind of shift around a little bit on you. So you got to check that. If you set your density too high, you're going to have material left over at the end because the belt's going to run slower because it thinks it's heavier than it is. If you accidentally set your density too low, you're going to run out early because it's running the belt faster, trying to put this stuff on, you know, thinking it's actually lighter or less dense than what it really is. So I can't really do this with one hand and hold the camera, but basically you got this slide on here with a level, and you stick your finger through, or a pencil, or you know, something around through this loop. And I knew about where this one was, so it's working. And you move that around on there until you get this bubble level, and then you can read the number off of there and get your density. So this one, when I last checked, it was around 65 pounds a cubic foot. Okay, so I actually have a little clip of this video with this thing being applied, and this is kind of cool because it shows the rate, shows where things have been shut off. So that's some of these different color changes you've seen. This is the whole field. It'll also show you just a view of the machine represented as a triangle as you're going through. But you can see some of those red spots and stuff like that. That's where it shut off automatically, and you know, running into triangles and just different odd shapes and stuff. And our purple spots are where we were off rate a little bit. So that might have been like a bump I slowed down for, and it was putting on a little too heavy until the computer adjusted the rate to the speed, or where I was putting on a little too light. Like some of those look like they're getting into straighter, longer stretches where I may have shifted up and it applied just a little bit light until the computer was able to adjust this belt that's down here to the and underneath this product to the speed that we were going. So it's really hard to show you guys this stuff while we're actually running, or light bar, I tried to get some video of that, and that's hard to see, but basically that's what I follow, and that tells me if I'm on the right spacing. And this is all using GPS with this computer to keep track of it. And right now you can see those yellow lights to the right. That would mean if I wanted to stay on this imaginary line parallel to the imaginary line right beside it, I've got to chase those yellow lights to the right. And I'm actually finished with this field, so I'm just kind of parked here, and that's why that one looks weird. But you chase the lights, and you want to have them, you know, all green in the middle, and you don't want to see the, you know, the yellow on either left or right. So if I got yellow lights on the right, I got to turn to the right. If I got yellow lights on the left, I got to turn to the left, and that keeps me on these imaginary lines that we call AB lines, and that's how we make sure we don't end up with a lot of skips and overlaps. Because as you could tell just looking across here from the cab, and you saw how small those little granules were down there, I mean, you could just barely see them, and you're definitely not going to be able to see them at speed. So you need some kind of a system to be able to tell you where you're at and where you have been out here. Alright, so here you can see this thing, you know, painting where I'm at, and it's got a set A in the middle of it. It's waiting on me to set, you know, an AB line so I can tell where I am, but on this outside edge, I'm not worried about it. It can also tell us, like, if I do a boundary, it'll tell us the number of acres in this field so that I can check that against the amount of product I have left and know how I'm coming out. I don't have that feature enabled right now because I've been in these fields a lot. I know the size of them and where I should end up on this whole job. But that is one cool thing it could do. So shout out to the math teachers that we're using all kinds of things here: density, perimeter, and area to figure out what we're doing. And actually this computer has to do all that and figure out volume and doing all sorts of things. So, you know, all that stuff that we teach in school that everybody thinks is nuts, you know, here's some real life, real world application. And this process is called application, so no pun intended. Alright, so you can see this thing just kind of painting where I've been. I've got my light bar on my front here blinking at me and telling me which way to steer. It's kind of tough to do while talking to you guys on this phone, so I won't spend a lot of time doing it. But lots of different things to keep track of. You got the blue number is my target rate. The green number is what it's actually putting on. And if you guys find this fun or interesting, you know, that there are lots of places that do agronomy that I'm sure could use some good qualified applicators to run this stuff for them. So these really minor streaks and overlaps that you guys see, I mean, they may or may not actually exist. It's not an exact science tossing this stuff out with these spreaders, but it gets it pretty close. If they get too wide, then yeah, we're worried that we definitely don't have enough product on there. But there's also some stuff that's going to affect that. Like if you're leaning on a hill, the GPS antenna's on the top of this, and say I'm leaning to the right, well, it's going to think the whole machine's on the right, and it might show a little skip, but actually, you know, where your spreaders and stuff are at are over a little bit to the left from where it actually thinks it is. So it gets you really, really close, and it's kind of a cool technology to have. The old timers would do this just by practicing and knowing how wide the machine would turn, and then finding things to sight off of to drive in a straight line. And I'm glad we don't have to do it that way anymore. All right, so we finally got to open this thing up a little bit. Got some fields that are a little bit smoother running, and there's a shot of our computer. We're just putting our second pass on. This one's a little bigger, so it took a while to go around the outside edge. And you can see how that works and how that looks. And I know I've said it before, but I might cut this that clip out. I haven't decided yet on my editing. Hats off to your math teachers, because we are using all sorts of things today. Area, volume, density. It is just a lot of math. So there's a whole lot of stuff that actually comes into this, you know, from putting the calc numbers into the computer, calculating the density on our materials, and it's just a lot of fun. You know, we're also using area, covering acreage, and it's a blast. Well, it looks like I made it to the end of this long run, even though they were going nice and quick. So Talk to you later. Okay guys, I can't let you out of this without a little bit of math. So it's a rainy day. It's actually the day after I shot all the video of that spreading. But remember when we talked about our fertilizer blends, every fertilizer is going to have these blend numbers when you get them. You know, whether you grab a bag of like 1919 from your garden supply store, or you're going into one of these fertilizer plants and ordering stuff for agronomy. And those numbers, I'm just going to make some up of a blend. Let's do like a mix of DAP and potash. So we can do like a 923-30. And of course, you know, we can change the blend of the two products and manipulate these numbers kind of depending on the crop and nutrient need. And we can also change the total rate that we're applying. But what I really want you to get out of this is that these are all percentages. Nitrogen, phosphorus, and potassium are the macro minerals. So they're always in this order on these fertilizer numbers. So N, P, and K. And all of these are a percentage of each nutrient that's actually in this total fertilizer. So there's a couple ways you can do this. If you just wanted to know how much fertilizers and a certain amount of product that you have, you just take the total amount of weight. So, you know, if I've got, let's just use 100 pounds because it's easy. Let's say I've got 100 pounds of this, and I want to know how much phosphorus, you know, was going to be in that 100 pounds. I take 100 pounds and I multiply it by the phosphorus number, but don't forget that's a percentage, so you put a decimal in front of it. That's 0.23 equals, you know, 23 pounds of phosphorus that's going to be in this material. Okay, so if you read the question here, I mean, here's the other way to do this, and this is, you know, simple, but I want you guys to understand the concept. So if the soil test calls for 65 pounds of potassium, and you know that you're putting on this blend, you know, how many pounds per acre of this do I actually put on? So, you know, the soil test, it's going to tell you how many pounds per acre. Everything's just kind of done per acre. I forgot to write that into my problem when I was writing this out. So if we want 65 pounds of potassium per acre, how much of this 923-30 are we actually going to need to put on to meet that need? And of course, in reality, it gets more complicated because we got to worry about our other nutrient requirements and get our blend right and that sort of thing. But if you guys understand this basic concept, you know, that's enough that you know how things are working. So this is not going to be too tough to figure out. You just take the amount that you need, your 65 pounds, and you're going to divide it by, think about which number you're going to divide it by now. I said potassium, right? So that's nitrogen, phosphorus, and potassium. So you're going to divide it by that, but remember it's a percentage. So you've got to put a decimal place in it. So 65 divided by 0.3. And we'll get our handy dandy calculator up here. All right, so 216.6. So you go with, obviously you're not going to set a machine up with that. Actually, you could blend these kind of however you want, but 200, we'll call it 216. Or if we can go ahead and round up, we'll just call it 217. So that would be the total amount of this blend that we would need to put on to end up getting our 65 pounds of potassium. So I know a lot of times, you know, in school, and I was maybe a little bit the same way, you know, people aren't a huge fan of math and doing some of the things we do in math class, but in agriculture, in construction, I mean, just in a lot of things, you know, math's a reality, you know, and it lets us kind of do cool things and, you know, figure stuff out, you know, just you'd be hard pressed to find something where you don't have to do any math, whether you're figuring out cost and money, or if you're figuring out stuff like this, it's kind of everywhere. So anyway, that's how you figure this out. And probably on your worksheet that'll make for this video, I'll have a question on there, something like this for you guys to calculate and figure out on your own. But you can always come back and check this out and figure out how to do it. We can also just kind of do like a quick check. Whenever I'm doing this stuff, like, you know, for real, I want to make sure I got it right. So one way to kind of double check and make sure that you didn't make a mistake on your calculations is to go ahead and do them backwards. to double check. So I know I've got 217 pounds is what I'm planning on putting on. My target was 65 pounds of potassium, so I just want to calculate it backwards and see if that's enough. So 217 times, my potassium is this one over here, my 30, so it's 217 times 0.3, and then that'll tell me how many pounds of potassium I'm putting on per acre if I put down that total amount of product, and that's going to be 65.1, so that's good. Things are making sense, and I'm definitely putting enough on. So a lot of the math when you're actually doing this stuff, you know, out in a field, so to speak, whether that field's a farm field or, you know, construction or something like that, you want to run your numbers and calculate them, kind of think in your head if they make sense, and then just you know, do a double check, because with this stuff, you know, once it's on the ground, it's on the ground. You can't pick it up and start over. I mean, it has to be right the first time. So that's one of those things that we want to be thinking about. Okay guys, so that was dry fertilizer application, and that is it for now. This time for real, I promise. So, like always, you know, hey, thanks for watching, and I will see you guys later.